There is a scar written into your DNA. Every human alive carries it. It is not a mutation. It is not a disease. It is a record of the single most catastrophic event in human history, an event so devastating that geneticists can still read it in your cells today, 74,000 years later. Most people have never heard of it, and once you understand what happened, you will never think about your own existence the same way again. To understand the scar, you have to understand what was living on this planet before it happened. By 74,000 years ago, modern humans had existed for roughly 200,000 years. We had spread across most of Africa. We had fire. We had tools. We had language. Some groups had already begun pushing north, testing the edges of the continent, probing the world beyond. We were not thriving, but we were surviving. Then the mountain woke up. On the island of Sumatra, in what is now Indonesia, there is a lake called Lake Toba. It is 100 kilometers long and 30 kilometers wide. It is one of the most beautiful places on Earth today. It is also the scar left behind by the largest volcanic eruption in the last 2 million years. When Toba erupted 74,000 years ago, it did not erupt the way volcanoes erupt in photographs. It did not produce a river of lava that crept slowly down a mountainside. It exploded. In a matter of days, it ejected somewhere between 2,500 and 3,000 cubic kilometers of rock, ash, and sulfur into the atmosphere. For comparison, the 1980 eruption of Mount St. Helens, the one that flattened an entire American forest and made international headlines, ejected about 1 cubic kilometer of material. Toba ejected 3,000 times that. The ash cloud spread across the entire Indian subcontinent. Archaeological sites in India from this period show a layer of Toba ash several meters thick, sitting directly on top of whatever tools and camps existed before the eruption. Below the ash, evidence of life. Above the ash, silence. The sulfur dioxide Toba released into the upper atmosphere was enough to trigger what scientists call a volcanic winter. Sunlight was blocked. Global temperatures dropped by an estimated 3 to 5 degrees Celsius on average, and in some regions, up to 15 degrees. Crops do not grow in volcanic winter. Forests die. The animals that lived in those forests starved, and the humans who depended on those animals had nothing left to eat. This was not a bad season. This was not a drought. This was the sky turning off. And here is where your DNA enters the story. In the early 2000s, geneticists began noticing something strange when they mapped human genetic diversity. Compared to almost every other species on Earth, humans are remarkably similar to each other at the genetic level. Chimpanzees, our closest living relatives, show roughly 4 times more genetic diversity within their species than we do within ours. Think about what that means. A chimpanzee population living on one side of a river in Central Africa can be more genetically different from a chimpanzee population on the other side of the same river than any 2 humans chosen at random from anywhere on the planet. You and a stranger pulled from the most remote village on Earth share more genetic common ground than 2 chimp groups living within earshot of each other. That is not normal. That is the signature of a bottleneck. A genetic bottleneck happens when a population is reduced so severely that almost all of its diversity is wiped out. The few survivors rebuild the species from scratch, and the new population carries only the genetics of whoever made it through. Scientists call this the Toba catastrophe hypothesis. The theory suggests that the Toba eruption reduced the entire human population on Earth to somewhere between 3,000 and 10,000 surviving individuals, not 3,000 to 10,000 in one region total. Everywhere combined. Every human alive today, all 8 billion of us, would be descended from that single desperate remnant population. The diversity we lost in those years was never recovered. It is simply gone, permanently subtracted from our species, readable in our cells like a scar that never fully healed. Now here is where it gets complicated. Because science does not close this case cleanly, some researchers push back on the Toba hypothesis. They point to archaeological sites in southern India and southern Africa, where human activity appears to have continued through the ash layer without significant interruption. They argue that humans were more resilient than the bottleneck theory suggests, that the population crash, if it happened at all, was regional rather than global. And they are not wrong to raise that challenge. The evidence is real. But here is what nobody disputes. Something happened to human genetic diversity around 70,000 to 80,000 years ago. Something reduced it dramatically. Whether Toba was the sole cause, a major contributing cause, or one catastrophe among several that coincided in the same terrible window of time, the result is the same. The human species came within a margin so thin that modern scientists are still debating whether it even constitutes survival. And then something else happened, something nobody predicted. The survivors didn't just hold on, they exploded outward. In the tens of thousands of years following the Toba event, the archaeological record shows one of the most dramatic expansions in human history. From that small surviving population in Africa, humans began moving into the Middle East, into Europe, across Asia, down into Australia, eventually across a land bridge into the Americas. By 40,000 years ago, humans had colonized nearly every habitable environment on the planet, from a near-extinction bottleneck to a global species in less than 35,000 years. No other species in the history of life on Earth has done anything like that, not at that speed, not from that depth. Scientists have several theories about why. Some argue that the bottleneck itself was the catalyst, that forcing the surviving population into close proximity created the conditions for an explosion of cultural innovation. Small groups under existential pressure share knowledge differently. They cooperate more tightly. They innovate faster. Others point to evidence of what archaeologists call behavioral modernity emerging in the post-Toba record. The first abstract art, the first long-distance trade networks, the first evidence of complex symbolic thinking appearing in the archaeological record right around the time of or shortly after the eruption, as if the catastrophe shook something loose, as if nearly dying taught us something about being alive that we had not understood before. There is a concept in biology called the founder effect. When a small group becomes isolated, geographically, genetically by catastrophe, and rebuilds a population from scratch, the traits of that tiny founding group become disproportionately represented in every descendant. You are not just descended from the Toba survivors. In a meaningful biological sense, you are them. Their fears, their innovations, their ways of bonding under pressure, their capacity for cooperation in the dark, all of it was passed forward generation by generation, diluted but never erased, until it arrived in you. The resilience that pulled a species back from the edge of nothing is not ancient history. It is your inheritance. When researchers sequence the human genome today and find that narrow corridor of shared genetics, they are not just reading a record of disaster. They are reading a record of survival. Every human alive is the descendant of people who endured a volcanic winter, who kept moving when the food ran out, who held together when the sky went dark, who rebuilt something from almost nothing. In the worst conditions this planet has ever imposed on our species, you carry that in every cell, not as a metaphor, as a literal biological fact. The sky over Sumatra went dark 74,000 years ago. The ash settled, the years passed, the temperatures dropped, and the forests died. And somewhere in Africa, a population so small it would fit inside a single city block looked at a world that had nearly erased them and kept going anyway. We don't know their names, we don't know their faces, but we carry their scar. And somehow, against every reasonable probability, that scar is the reason you are here.